And a key thing to understand here is that this excessive power disrupts the market and overall welfare. This ability to modify the prices by modifying your quantities produced hinders the consumer surplus, and it allows firms to basically steal, or not steal, but appropriate or a important part of the consumer surplus. So essentially, to model monopolies is we need to think in a different way in terms of production that we've been doing during this course. We've mainly focused on cutting cost and being able to compete in price and get new customers and basically get a higher market share and become more successful, earn better profits that way. Monopolies don't compete in cost because they don't compete at all. So what happens is that to maximize profits, they basically focus more on maximizing revenues. So as I mentioned in this slide, the idea for a monopoly is at what price can I basically price my product in such a way that I obtain the highest profit margin, but I don't alienate too many customers that in the multiplication of quantity times price, I actually lose money. So it's this idea is how high can I move the price that I still have a sufficient number of customers that will continue to buy my product, and therefore the multiplication is maximized and I maximize profits. That is the problem that monopolists are solving. It's a maximization of profits, but in a different way. They are focused not on equating the price to the marginal cost. They are equating the marginal revenue to the marginal cost. And basically, this happens because monopolies restrict the overall quantity available in the market. To increase prices because of the law of the demand, if something becomes scarcer and there's less units available, people will be willing to pay more. It becomes relatively, let's call it something luxurious, or at least something that is worthwhile. And you continue to restrict the price, sorry, the quantity, and more people will want to buy that or will need to buy that. And depending on these combinations, you find a particular price in which you obtain the biggest profit. And once you see what is that level of quantity, you determine that price. To do so, you focus on revenues. So as you can see in this slide, I have placed a comparison between how competitive firms attempt to maximize profits and how monopolies attempt to maximize profits. The original equation is essentially the same. They want to maximize their profits, which is the difference between revenues, the units being sold, Q, times the price at which you're selling them, minus their total cost. But as you see on the two sides of this slide, in the competitive markets, I decided to use the lowercase q to determine the quantity of a firm. But in the monopoly, I decided to use the uppercase q. And it's by design, because normally in economic textbooks, Q, the uppercase Q indicates the industry quantity, the total quantity of that market. And a competitive firm is not the only supplier of that market, but the monopoly is. So as you can see, the moment you can modify the price because of how big is your production, this applies to monopolies, but not only monopolies, the duopolies are like that. The moment you have market power and you can modify the price when you decide to increase or decrease. This is Saudi Aramco in the global oil market, literally plummeting the price when they decided to flood the market with their production, increasing production. They basically face a different problem. In terms of the math, as you can see, the optimization problem from the competitive markets, P is not determined by Q. So once you differentiate by Q, you get a P times Q just becomes Q, and the total cost becomes a marginal cost, and any optimization problem, you equal it to zero, and that's how you get that price equals the marginal costs or competitive markets. But as you see on the orange part of the right hand side of the graph of the slide, the ability to modify the price makes the price an endogenous variable. Therefore, the differentiation is a product rule type differentiation, and it's not the same. So what happens is that that thing in orange is equivalent the marginal revenue. So the optimization problem of monopolies implies equating the marginal revenue to the marginal cost of production. This is more or less how you see those two ideas graphed one against the other. So what happens here is that in the case of the competitive firm, you basically have a marginal revenue which is constant and that only equals the price. We literally saw that price equals marginal cost in the previous graph. But in the long run, monopolies obviously have profits. So their demand curve doesn't become a horizontal curve. It continues to be a regular diagonal downward sloping demand. Therefore, they always have profits. And I show that in the calculations below in terms of the areas of the triangle. But the point is that their marginal revenues are different. The monopolists control their marginal revenues. Their marginal revenues are not constant. They change depending on how much units they produce. And that's why it's so important to monopolists to determine what is the optimal quantity to produce that I can have the higher price possible, that in the combination quantity price, I basically maximize my profits. To do that, let's do an example. And with this, we will basically end this lecture. So suppose that you have this demand curve. The P with regards to Q equals 24 minus Q. To basically determine the optimal quantity of production of the monopoly firm, you need to first find the marginal revenue. And to do so, you need to work first with the revenues. So what I start doing in the slide is basically finding out the revenues of this particular firm. So remember that revenues are basically just the units you sell times the price at which you're selling them. So P times Q. But as we saw, you can substitute what P is from the demand curve, 24 minus Q. So your revenue function, R of Q, becomes 24Q minus Q squared. From there, you can basically find the marginal revenue by differentiating with respect to Q, and you get 24 minus 2Q. If you take a look to the demand curve on the upper part of the slide, and then to the marginal revenue curve at the bottom of the slide, you notice they are really similar. And that is because, by definition, the marginal revenue stems from the demand curve. You can't find the marginal revenue without the demand curve. A marginal revenue looks like the purple graph, while the demand curve is the blue curve that you've seen throughout this course. So once basically you have the marginal revenue, in this case the purple or line, you can equate that to the marginal cost of production of this monopoly firm, and with that determine essentially the equilibrium quantity and the equilibrium price at which this monopoly will determine to produce and to sell. So you obviously need some form of the total cost function, or the marginal cost, or a supply curve. So if you have the total cost function, suppose that it's in this case a Q squared plus 12, you differentiate that and you find the marginal cost of production, 2Q. And as you see from the algebra on the bottom part of the slide, you equate marginal revenue to marginal cost. You do a little bit of algebra, and you find the monopoly quantity, in this case is 6, and with the monopoly quantity, you plug that back in the original demand curve, and as you can see, you find the monopoly price. With this, you've basically solved the monopoly problem. It's like you already found the equilibrium. There's probably like 10 points in any problem set that I do. But once you have the monopoly equilibrium, you can do other stuff with it. you can compare it to the competitive equilibrium. So that's what I did in this particular slide. I have on the right-hand side the monopoly math that we just did, and on the left-hand side, you have what would have happened if this was a competitive market. Remember that in competitive markets, what you do is you still equate marginal revenue to marginal cost, but in competitive markets, the marginal revenue is literally just a price because it's constant. So that's why you have price equals marginal cost, and you have a different equilibrium. In this case, Q equilibrium is 8 and the equilibrium price is 16. Take a quick look onto the difference between the quantities and the prices in both extreme cases. So what you see for this particular example is that the monopoly quantity will always, and this is a true statement for every single scenario, the monopoly quantity will always be smaller than the optimal competitive market quantity. The monopoly will produce less units. They will restrict the availability of the product to extract higher profits. And as you can see, the prices have the same tendency. The price in competitive markets is lower than the price in monopoly markets. They can charge a higher price because they have less quantity available. That good is scarcer. So when you translate that into the profits, and I literally place the profit function of both cases on the bottom part of the slide, the overall profits for the monopoly are higher than the overall profits for competitive firms, even in the short term. Remember that in the short term, firms actually, even in competitive markets, they do have profits. So that is why, as you can see in this very textbook-like example, this is why most firms want to be monopolies, or at least be as close as possible to monopolies, because that is the place where you maximize your profits. And you maximize your profits, I think it's the next slide, because you obtain a very high percentage of the welfare share. So take a look at this graph. You see in green and in red the typical cost functions that we've seen throughout this course. Here we did a linear marginal cost instead of a curve, but you have the typical curve for the average variable cost and the average cost in general. You have a demand curve and you have the marginal revenue. We're currently seeing the monopoly equilibrium. And as you see, the main point to focus is here. The place where the red line, which is the marginal cost or the supply curve, intersects the marginal revenue, this purple curve, this purple line. At that point is basically where you should produce. In this case, this level. This is the monopoly quantity. So once you figured out the monopoly quantity, as we did in the math in the previous slides, you then look, okay, now I have this amount. Now I see what is the consumer's willingness to pay for this level of available goods. So to determine that, you go to the demand curve, and remember that the demand curve is equivalent to saying the willingness to pay curve from the consumers. So you know, oh, it's $18 or 18 pesos for this particular product at this level of production. That is the two key things that the monopoly does. It finds its equilibrium quantity and its equilibrium price. And they do so this way. They extract as much as possible of consumers by understanding through the demand curve how much are they willing to pay. If we graph the monopoly consumer surplus, we have this triangle. The area under the demand curve above the price is the consumer surplus of monopoly. Let's draw, and let me draw the producer surplus. Now, I'm going to draw the also in red. The producer surplus, remember, is the area above the marginal cost of production, but below their price. So the price they're selling is 18, and this is the red line is the marginal cost. So therefore, the producer surplus is this big triangle or like triangle-like figure. This is the producer surplus in a monopoly. I'm going to try and draw in blue what would have been if you had a competitive market. You would have focused in this point where the supply curve intersects with that demand curve, as you've done since the beginning of this course. That implies that the equilibrium quantity would be more or less here. Imagine this is a straight line. It would be like here, some place between the 6 or whatever this number is and the 12. And the equilibrium price would have been here. I think it was 16, I think, that we found. This would have been the equilibrium price, P star. If this is the case, the consumer surplus in a competitive market would be the area under the demand curve above the price. This triangle. As you see, this triangle is bigger than the previous one. Consumers were, let's call it, robbed of a part of their consumer surplus. That was transferred to suppliers. That is a transfer, so it's not a deadweight loss. But there's a small amount here that was part of the deadweight loss. And the producer surplus would have been a smaller blue triangle here. It would have extended a little bit here, and this would have been the producer surplus, but it's smaller than the other one. And this side, instead of being a deadweight loss, would have been part of the producer surplus. The point is here to make, the final point to make here is that the producers are willing to incur in a little bit of deadweight loss by basically restricting the quantity to obtain a bigger chunk of the consumer surplus that covers that deadweight loss and compensates for that. So what you have is that monopolies greatly affect consumers. They make things much more expensive than what they should be, and because of this, they lose a lot of their consumer surplus. Questions before I erase the different things to pass like to the last slide, I think.